Happy morning, students. Today's topic short review on S block elements, alkali and alkaline earth metals, especially for IIT JEE and NEET students. First, we are going to give you a short review on alkali metals. Before going to this, what is S block elements? The differentiating electron enters into S orbital is known as S block elements. Differentiating electron means last electron in the atom. Example, when you take the sodium atom, its atomic number 11, electronic configuration is 1s2, 2s2, 2p6, 3s1. This electron is known as differentiating electron. Based upon last electron, all the elements are classified into 4 blocks: S block elements, P block elements, D block elements and F block elements. So here, when the differentiating electron enters into S block, S orbital, such kind of elements are known as S block elements. Our topic is alkali metals. Lithium, sodium, potassium, rubidium, cesium and francium. These elements are belong to long form periodic table in first A group. Because of last electron present in the S orbital, all are belong to S block. And why these elements are called alkali metals means when these elements placed in water, it forms bases, strong alkalis. When these elements exposed to the atmospheric air, they form oxides. Oxides also basic in nature. Because of this reason, these are called as alkali metals. Simply forming of oxides and hydroxides, these metals are known as alkali metals. 1A group elements electronic configuration, lithium atom atomic number is 3 and its electronic configuration 1s2 to s1. And the next element, when you take sodium, before going to that, the same electronic configuration we can write with respect to the lithium. Lithium atomic number 3, helium atomic number is 2, that is the reason 2s1. Sodium atomic number 11, its electronic configuration is 1s2, 2s2, 2p6. With respect to neon, we can write the electronic configuration, that is sodium atomic number 11 with respect to neon, core 3s1. Next element, potassium atomic number 19, its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. With respect to noble gas, potassium atomic number is 19, argon 4s1. Next element is rubidium, atomic number 37, electronic configuration 1s2, 2s2, 2p6, 3d10, 4s2, 4p6 and 5s1. With respect to noble gas configuration, rubidium 5s1. Cesium atomic number 55 and its valence electron enters into the 6s1. With respect to the noble gas, krypton after xenon 6s1. The last element in this group is francium. This is the radioactive element. It is the last electron enters into seventh shell. With respect to the radon, its atomic number 87, we can write 7s1. So all the elements in this alkali metals ends with s1. That is the reason the general electronic configuration of alkali metals is ns1. Like this, 1, 2s1, 3s1, 4s1, n is equal to 1, 2, 3, 4, 5, 6, 7. This is about electronic configuration. Second one, physical properties. And third one, chemical properties. Fourth one, uses. Simply, we can close it. This atomic and ionic radii. In each and every group, atomic radii and ionic radii is gradually increases from top to bottom. Lithium is the top element and francium is the least element. From top to bottom in this group gradually increases either atomic radius and ionic radius both. When you see the ionization enthalpy of this group is inversely proportional to atomic radius. When atomic radius increases, ionization enthalpy decreases. Here the lithium is smaller atom, its ionization energy is high. Third topic is hydration enthalpy. Hydration enthalpy depends upon the ionic radius of the atom. So here the lithium ion atomic radius is less, hence its hydration energy is high. This is the order of hydration energy. In this group, lithium ion is having higher hydration energy and the cesium ion is having lower hydration energy. Ionic mobility and conductance. Here the lithium ion is holding more number of water molecules. Ionic mobility we can explain in this way. This lithium ion, because of smaller ionic radius, it is holding more number of water molecules. More number of water molecules. More number of water molecules. These are all water molecules. So now a big cluster is forming. In hydrated form, this lithium ionic radius is this much. It is a very big. In case of cesium, cesium ion is this much size. Because of bigger size, this cation attracts a less number of water molecules. Less number of water molecule, hence its atomic radius is less. So because of smaller size, it will move fast. It will move fast. Hence the mobility is high in cesium. Mobility is high in case of cesium, less in lithium. So that is a mobility character. This is the lithium ion. This lithium ion mobility is less, while comparing with cesium ion is having higher mobility. Lithium after what will come? Sodium ion. Sodium after what will come? Potassium ion. Potassium after what will come? Rubidium ion. This is the mobility or the conductance. See here the order. Cesium is having more mobility, lithium is having less mobility. Coming to the density. Density means heavier atom. Obviously, lithium is having more atomic number, more atomic mass. Hence, the density value is also having high. And lithium ion is having lower density. Coming to the melting point. The melting point is in this order. Lithium is having high melting point value and comparing with the cesium. Cesium can melt easily while comparing with the lithium atom. Then we'll go to the boiling point. This is the order of boiling point. In this case also lithium is having high boiling point comparing with cesium. This is about the physical properties. Very simple. This chart is enough to remember the physical properties. Atomic radii, ionization enthalpy, hydration enthalpy, ionic mobility and conductance, density, melting point and boiling point. Coming to the next chemical properties. So only you have to remember this flow chart. When you remember this flow chart, all the chemical properties will come under this. Here I am taking one sodium metal. One sodium metal I am taking the chemical property of the sodium metals. The sodium metal is belong to alkali metal. One metal I am taking the same similar chemical properties possessed by the other elements. So let us see sodium when reacts with air. Air means that is water. So that is oxygen. In air, oxygen is there. When sodium reacts with oxygen, we will get a sodium peroxide. And as well as sodium is the active metal, hence when it reacts with oxygen, it forms two types of oxides. One is monoxide, M2O type of formula, and another one is peroxide, M2O2 general formula. Because of this high reactivity, it can form monoxide and peroxide. Then when it reacts with water, The sodium metal reacts with water, it forms base. It forms base. Sodium, when reacts with water, HOH, you will get the base. That is the reason it is called as an alkali metal. Alkali is forming along with hydrogen gas is liberating. So in this case, 2 moles of water molecule, 2 moles of sodium is involved in this chemical reaction. So forming of base is formed and as well as hydrogen gas. Second chemical reaction reacts with metals. When reacts with non-metals, what are the non-metals we have? One is chlorine, the another one is sulfur, Se8 or S, and the third one is phosphorus, fourth one is hydrogen. These are all comes under non-metals. When non-metal, the sodium metal is reacts with non-metal, what are the products will come? And sodium reacts with chlorine. Very simple, you can expect the equation. Sodium reacts with chlorine, you will get a sodium chloride, ionic crystal. The same way, when sodium reacts with chlorine, sodium chloride, when it reacts with sulfur, sodium reacts with sulfur, you will get a sodium sulfide. The same way, when sodium reacts with phosphorus, phosphorus molecular formula is P4. It existing in the P4 structure, you will get a sodium phosphide. Sodium phosphide. Here, the phosphorus valence is -3. Same way, sodium reacts with hydrogen, you will get sodium hydride. Sodium hydride formula is NaH. Here H act as minus. So these are the reacts with non-metals. Very simple. First one, action with air. Second chemical property, action with water. It means sodium reacts with water. Third one is sodium reacts with non-metals. Chlorine, sulfur, phosphorus and hydrogen. Sodium, you know very well about that. It is an electropositive metal. When it reacts with non-metal, chlorine, ide will form. Sodium chloride. Same way, sodium reacts with sulfur, you can expect sodium sulfide, ides will come. When sodium reacts with phosphorus, sodium phosphide. Sodium reacts with hydrogen, sodium hydride. Ides always form when sodium reacts with non-metals. The same way, next one, when sodium reacts with acid, HCl, you will get sodium chloride and hydrogen gas. Sodium, when reacts with hydrogen chloride, you will get a sodium chloride plus H2. So here the sodium is replaces hydrogen gas. Sodium replaces hydrogen gas. So you will get in this reaction, you can express one chemical property. In this sodium, the sodium valence is 0. In the sodium chloride, the sodium valence is +1. The increasing in the oxidation state indicates oxidation. Who involved in this oxidation process? Sodium involves in the oxidation process. Whatever the participant involved in the oxidation process, that participant is known as a reducing agent. This is the reducing character, reducing agent. So that is the reason alkali metals are acts as a strong reducing agent. Reducing agent means they displaces hydrogen gas. 2 points I am saying in this aspect. One is displaces hydrogen. See here, hydrogen is liberated. Second point, the reducing agent means electron donor. Electron donor. See here, sodium is 0 valency, here +1. When the sodium is changed into +1, when sodium loses 1 electron, it changed into sodium ion. That is the reason the 0 is converted into plus. So increasing in the oxidation state. So because of donating electron. Remember in this case, reducing agent means hydrogen, it displaces hydrogen. The second one is electron donor. So this example shows sodium metal acts as a reducing agent. Second one, the sodium metal can also react with alcohol. Alcohol formula is here C2H5OH. you are getting sodium ethoxide plus hydrogen gas. I am writing this equation again. See here, sodium plus ethyl alcohol C2H5OH. The product, expected product, what we have to see here, sodium, what I told my dear student, it is the hydrogen, it displaces hydrogen. So here the hydrogen is there. So hydrogen you have to displace it. The remaining part is added to this. So what the product will come? C2H5O and here Na. C2H5ONA. This H is become H2 gas. Isn't it? After that you can balance it. This is the main Skeleton equation. This equation also shows sodium metal acting as a strong reducing agent. It displaces hydrogen gas. This name is sodium ethoxide. This is the sodium ethoxide. Next, reducing action of Na. Some more equations I am showing here. It reacts with silicon dioxide. You are getting sodium oxide into silicon. See here, sodium metal when reacts with silicon dioxide SiO2, you are getting sodium oxide Na2O plus Si. Look at the students. Here the sodium oxidation state is 0. In this case also sodium oxidation state is +1. Sodium oxidation state always here 0 in elementary state. Here Na plus O minus 2. In this case sodium oxidation state is also +1. So increasing in the oxidation state indicates oxidation. So because of losing of electron, it is known as a reducing agent. So here what will happen? What will happen? In the first case, what I explained you, my dear students, it displaces hydrogen. Displaces H2, right? Second one, electron donor. Electron donor is a strong reducing agent. Very good. And third one, what you have to remember is oxygen acceptor. Oxygen acceptor. Always hydrogen and oxygen reverse should be there. Hydrogen is removing means displacing means oxygen should acceptor. See here, sodium when reacts with silicon dioxide, it accepting oxygen. Because of that, you are getting sodium oxide. Addition of oxygen also known as oxidation. Oxidation. Who involved in this oxidation process with respect to oxygen? Sodium. Sodium is involving. That is the reason who are participating in the oxidation process, that participant is considered as a reducing agent. So these 3 points you have to remember: hydrogen displacer, electron donor, and oxygen acceptor. Fine. Same way, when you see other example, when it reacts with when it reacts with beryllium chloride, you will get sodium chloride plus beryllium. See here, sodium plus beryllium chloride, you are getting sodium chloride plus beryllium. Sodium in the elementary state or atomic state, its oxidation state is 0. In sodium chloride, the sodium oxidation state is +1. So increasing in the oxidation state is known as oxidation. In this oxidation, the participant is considered as a reducing agent. Here also the same equation, aluminium chloride NaCl plus Al will form. So these are the important 4 chemical reactions you have to remember. Only 4, my dear students. One is with water, second one is with air, third one is non-metals, reacts with non-metals, and the fourth one is reducing nature. Reducing nature. After completion of this, without seeing, you have to practice the equations for chemical properties. That's end first year group elements. Good. Now coming to the second year group elements. Second year group elements, chemical properties. sorry, first year group elements, one more chemical property is there, that is action of ammonia. This is a very, very important questions. Most of the times asked by the competitive exams. See here, action of ammonia. Ammonia is available in the liquid form. Ammonia is available in the liquid form. Liquid ammonia. When this ammonia reacts with this active sodium metal or alkali metal, that will be dissolved, you will get a liquid. That liquid is having blue color liquid will be formed. Blue colored liquid. Blue colored liquid. This blue colored liquid contains two different ions. One is positive ion and another one is negative ion. Most important question it is positive ion, negative ion. Positive ion is known as ammoniated sodium ion. Ammoniated sodium ion. The negative ion is known as ammoniated electron. Ammoniated electron. Because of presence of ammoniated electron, this liquid gets blue color. This is the responsible, not this one. Presence of ammoniated electron only, the colorless ammonia liquid becomes blue in color. Blue in color. What is this ammoniated sodium ion means? Ammonium ion containing sodium. Ammonium, electron containing ammonia. Sodium containing ammonia. Electron containing ammonia. In this ammonia, sodium is there. In this ammonia, electron is there. That is the reason ammoniated electron. In this ammonia, sodium is there. Ammoniated sodium. Here, X indicates number of molecules. Here, the Y indicates number of molecules. So, how many number of molecules are reacting in this case? Those number of molecules will come under this. So, this is unstable. After some time, this color is disappears into and forms sodium amide. However, when ammonia is passed through the molten sodium, it yields sodamide evolving H2 gas. This is unstable. This is the final reaction. When reacts with ammonia in presence of 475 Kelvin, this ammonia is converted into sodium amine or sodamide with hydrogen gas. This is the last chemical property of this first year group elements. Now we are going to discuss about the first year group elements uses. So first year group elements, what are the things we are discussing? First one is electronic configuration, physical properties, chemical properties and uses. 4 topics. We'll see. Uses of sodium. Sodium is used as a reducing agent in the extraction of boron and silicon. While taking boron and silicon from their ores, sodium metal will be used. Liquid sodium or its ally with potassium is used as a coolant in nuclear reactors. Sodium as well as sodium amalgam are used as a reducing agent in organic synthesis. It is used in Lassen's test for the detection of nitrogen and sulfur and halogen in organic compounds. What is Lassen test? That we will see in our organic chemistry. Sodium is used in sodium vapor lamps. It is largely used for production of artificial rubber, dyes, drugs, etc. These are the important uses of sodium metal. Sodium lead alloy is used for the preparation of tetraethyl lead. Its formula is Pb C2H5 taken 4. C2H5 is ethyl, 4 means tetraethyl lead. This tetraethyl lead is used as an anti-knocking agent in petrol. Now, the anomalous properties of lithium, each and every group, we have a special characteristic element, first element. What are the special properties of lithium? Lithium is the hardest of alkali metal. Lithium is least reactive but the strongest reducing agent among all the alkali metals. On combustion in air, it forms mainly monoxide. It means lithium oxide only form. It will not form peroxides and superoxides. It is also reacts with nitrogen and form nitrite. Lithium chloride is deliquescent and crystallizes as a hydrolated. It is available, these salts are available in the hydrated form. Example, LiCl2H2O. Whereas other alkali metal chlorides do not form hydrates. Other alkali chlorides, for example, sodium chloride, we have to writing with only representing with only NaCl, not NaClH2O. Lithium hydrogen carbonate is not obtained in the solid form, while all other elements form solid hydrogen carbonate. Solid hydrogen carbonate. See here, sorry. See here, when writing the lithium hydrogen carbonate, its formula is LiHCO3. When sodium hydrogen carbonate is NaHCO3. This is sodium hydrogen carbonate. This is available in the solid form, baking powder, available in the solid form, but it is not available in the solid form, it is available in the aqueous form. Lithium, unlike other alkali metal, forms no ethylenide on reaction with ethane. Lithium nitrate, when heated, gives lithium oxide, that is Li2O, whereas other alkali metal nitrates decomposes to give corresponding nitrate. See here, when lithium nitrate on decomposing, it will producing lithium oxide. Oxide is forming, while other will not give oxides. Lithium fluoride and lithium oxide are comparatively much less soluble in water than the corresponding compounds of the alkali metals. Except lithium sulfate, other sulfates are soluble in water. These are all special characteristic properties. Especially regarding lithium, any question will come, you have to think and write your answer perfectly. Last one, diagonal relationship between lithium and magnesium. Diagonal relationship between lithium and magnesium is both lithium and magnesium are harder and lithium lighter than other elements in this group. Lithium and magnesium react slowly with water. Their oxides and hydroxides are much less soluble. Hydroxide are decomposes on heating. So this is about the example of diagonal relationship. The first A group element lithium is interlinked with the second A group element second element. First element in one group, similar characteristic properties with next group second element. This phenomenon is known as diagonal relationship. Once again I am saying, first element in one group, similar characteristic properties with next coming element, second element in the group is known as diagonal relationship. In the same way, first element, next group, second element. This is the first element, next coming group, second element. This is the first element in this group, next coming group, second element. These are having similar characteristic properties. Some more properties. Both form nitrite. Example, lithium nitride and magnesium nitride by direct combination with nitrogen. Both lithium and magnesium give only monoxides. Example, Li2O, MgO, and they do not combine with excess of oxygen to give any superoxides. The carbonates of lithium and magnesium decomposes easily on heating to form the oxides and carbon dioxides. Solid hydrogen carbonates are not formed by lithium and magnesium. Both lithium chloride and magnesium chloride are soluble in ethanol because their covalent character. Both lithium chloride and magnesium chloride are deliquescent and crystallizes from aqueous solution as hydrated Li2H2O and MgCl2 8H2O. So these are the important properties related with lithium and magnesium. So alkali metals chapter is over, and alkaline earth metals I am going to explain you within 5 minutes. Observe carefully. So this alkaline earth metal also belong to s block element because the last electron present in s orbital. Hence these elements also belong to s block. And why these elements are called as alkaline earth metals? These elements also dissolve in water. You will get base, and when these metals are exposed to the atmospheric air, you will getting magnesium oxide, calcium oxide. Oxide forming nature is available, and as well as base nature is also present in this case. That is the reason these are called alkali. Earth metal means which are exist in the earth. Hence, these elements are called as alkaline earth metals. The possessing alkali nature and available in the earth. Same way, observe the electronic configuration. Alkaline earth metals general electronic configuration is Ns2. Beryllium, magnesium, calcium, strontium, barium and radium. Here also the radium is belong to radioactive. When you observe the electronic configuration 1s2, 2s2, valency shell is 2s, it contains 2 electrons. The magnesium electronic configuration is 1s2, 2s2, 2p6, 3s2. The valency shell of electron is 2. Same way calcium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And strontium atomic number is 38 and its last valency shell is 4s2, 4p6, 5s2. And then barium atomic number is 56, its valency shell is 6s2. Radium electronic configuration, when you observe its valency shell is 7s2. So presence of 2 electrons in the all elements, hence its general electronic configuration is Ns2. N means this number only changing 2, 3, 4, 5, 6, 7. With respect to the noble gas configuration also, we can show these all elements electronic configuration. So helium 2s2, because helium number is 2, beryllium number is 4, 2 plus this 2, 4. With respect to the neon core 3s2. Next, with respect to argon, the electronic configuration of calcium is 4s2. With respect to krypton, the strontium electronic configuration is 5s2. With respect to xenon, the barium electronic configuration is 6s2. And with respect to radium, the radon 7s2. Simple electronic configuration, you can write both are the correct process only. Which will comfortable for you, you can follow that. Second A group elements physical properties. What are the physical properties we studied in alkali metals? Here also we are going to see. Atomic radii and ionic radii both increases down the group from top to bottom. See here beryllium to barium atomic radius are increases. The second one is ionization enthalpy. When atomic radius increases, it is inversely proportional. So the atomic radius are increases, ionization enthalpy values decreases. So larger the atom will having less ionization potential, smaller the atom will always having high ionization potential. Hydration enthalpy, smaller the radius of an atom exhibit high hydration enthalpy. So in this case the smaller ion will be beryllium. The beryllium is having higher hydration enthalpy, barium is having lower hydration enthalpy. And then coming to the physical constants, under that one is density. The density values means atomic number increasing and mass also increasing. Hence, the barium is the bigger atom, its density is high comparing with other elements. When coming to the melting point order, the melting point is following this order. Beryllium is greater than calcium and least melting point element is magnesium, highest melting point element is beryllium. The same way, boiling point also in this order only. Next one, we have to see about the second A group elements, which are known as alkaline earth metals. And another name also there for magnesium. This magnesium is treated as a bridge element. It acting as a bridge between 1A and 2A and as well as these calcium, strontium, barium and radium, zinc, cadmium, mercury. These elements are belong to what? Alkali metals, second A group elements I mentioned here. And these elements are belong to second B. Second A elements and second B elements. Second B elements means zinc, cadmium and mercury. When you go for the periodic table, this is the periodic table. When you observe, left side we have S block elements. In the middle we have D block elements. Extreme right hand side we have a P block elements. And bottom you will get F block elements. S, P, D, this is D and this is F. See here, 2B means 10th group is 10B, 11th is considered as 11B, that is 1B, and in the last one is considered as 2B. 2B means here what are the elements will be there? 3 elements should be available. Scandium to zinc, cadmium and mercury. These elements are belong to long form periodic table second B group. So second B group, and this is alkaline earth metals where magnesium acting as a bridge. It means these two are having similar characteristic properties. So here these are transition elements, these are transition elements. So the magnesium can similar characteristic properties with alkali metals and as well as second group elements. Hence the magnesium is known as a bridge element. Now chemical properties of second A group elements. Here also I am taking one magnesium. With respect to magnesium, I am going to finish it now, continue the class. Magnesium chemical properties. When magnesium reacts with oxygen, you will getting magnesium oxide. When magnesium reacts with carbon dioxide, you will get magnesium oxide plus carbon. Magnesium reacts with sulfur dioxide, you will get the magnesium oxide plus sulfur. And magnesium reacts with nitrogen. The product is magnesium nitride. Magnesium also positive metal. Ides will come. Then you have magnesium oxide, magnesium nitride. When chlorine, it reacts with the chlorine, the product will get magnesium chloride. And when it reacts with water steam, the same base you are going to get. This is the alkali, basic in nature. And when it reacts with acid, it is also acting as reducing agent. It displaces hydrogen gas. And when it reacts with sulfuric acid, here also hydrogen gas will be displaced, hence it is called as a reducing agent. And nitric acid, the same way, either hydrogen chloride or sulfuric acid or nitric acid, in all the three cases hydrogen is displaced. These three chemical reactions are the example for acting magnesium as a reducing agent. When it reacts with concentrated sulfuric acid, when you observe the chemical reaction magnesium with concentrated sulfuric acid, you will get a magnesium sulfate plus sulfur dioxide and water. This is the difference between dilute sulfuric acid and concentrated sulfuric acid. So when it reacts with dry ether, same way like sodium, it is also reacts with ethyl iodide, C2H5I. You will get a ethyl magnesium iodide. This is called as a Grignard reagent. A Grignard reagent. Grignard reagent means RMgX. The formula is R. Ethyl means R. This is Mg. X means halide. This is Grignard reagent. When it reacts with silicon dioxide, same way, oxygen should be added to the magnesium. Oxygen acceptor is also known as a reducing agent. This example shows magnesium act as a reducing agent. So these are the chemical properties of magnesium. Physical properties, chemical properties, and then you can learn about the uses also. So this is about your first A group and second A group elements. Entire